I would suggest that we probably try and divide the debate we will have now into slightly two parts. It's a model. The one would be to, and I suggest we do this first, to discuss this deconstruction of the gene we've heard here, right? The modelism, right? Or what I have learned is that a paradigm, and I would call it a paradigm in a way, the dogma, right, does not fall because it's falsified. It only falls once it is replaced by a better paradigm, right? And that is something I would be interested to discuss further, because I think many genetic engineers and many people making a lot of money of it would today agree that Crick's dogma is not all there is, right? Or would claim it's falsified. But so how do we replace it, right? I think that is the first round I would like to make. And then a second round of discussion is what are the economic, the political, the social, the cultural implications of this, right? Have we, as the GMO critics, for instance, been making the dogma stronger with our opposition to it? What implications does this really have on intellectual property claims, which are the basis of all the business, right? If the reasoning is wrong, right? These kinds of questions I would suggest we do in a second round, and now we do probably a first round on this question of where is the dogma, are there genes, what do we know? The lady back there was the first to raise her hand, and then you would be questioning, and then you would be. You could probably very briefly say who you are, where you come from, and kindly abstain from longer speeches. Thank you.
Yeah, that's
I'm at the moment I'm a researcher in the UK, but I studied in Berkeley. Right. So I'm against dogmas are always a difficult thing, but altogether there is something that determines how a plant will react or what potential it has to react to environment and to intrinsic signals and so on. Just because we don't know all of those things, it doesn't mean that it's not there. So otherwise breeding doesn't make sense. Yeah. So if we breed, we expect a plant to react in a certain way. Otherwise it doesn't make sense for the high yield plant and the other high yield plant across those guys. So there is something to completely say, there is this cloud of things. We need to kind of simplify things to work with them. So we also have to work with wrong models or with not complete models. So it is a difficult one. And then we're doing QTL analysis, which is coming from breeding, and we identify partially single loci. And we can get it back, and no geneticist, no serious one, would claim, oh, this is the gene if they don't find the gene and then can't complement or take back or bring out the phenotype. So there is something to it. It's not like the gene is certainly not the base for all of the changes, but there is a good chance. There is a chance for us to change a gene and sometimes have the effect. It will not work in 100% of the cases. And that would be crazy to promise those things. But there is a connection. We know a lot of biosynthesis pathways and stuff because of that. So.
Can I pick up, or we're just going to do all questions?
Let's collect a few questions.
I'll forget
so we have
it.
you have a pen here.
No, let's just quickly go into it.
No, I think
Yes.
it's okay.
It's all right.
My name is Regina Kolek, and I'm molecular biologist by training, but now retired professor of biotechnology assessment at the University of Hamburg. And I would like to come back to this notion of biology is in a conceptual crisis, which you raised in the beginning. And I would say, the problem, but also the beauty of genetic is that we have these simple models. We have this deterministic one gene, one gene phenomena, which were, in the very beginning of molecular genetics, which were the very fine cases we could draw upon. And try to reduce everything on this hypothesis. But now I think it's now for a long time that many of biologists know better about it. And not since the human genome has been sequenced, we know that there's no one gene, one gene relation, but things are much more difficult. And my point is that I have been working on systems biology. We did a lot of interviews and went into the laboratories and talked to the people who are now doing very basic research in systems biology, but also in systems medicine. And well, I think their people are different, yeah, and they think different, they talk differently about genes and the monocausal problem, monocausal relationships, and they do modeling and silico, and for sure this is still a mechanistic kind of approach. But I would like to know from all of you perhaps what you think, whether it could be some sort of a new kind of conceptual thinking about biology. But I mean, for sure we will never be the absolute wholists. Yeah? We will never capture everything which is there in nature. But could it probably be a better approach, and how could we do maybe risk assessment with this sort of models?
One more?
Yes, I would like to argue that the
who are you?
of the dogma. My Christoph Weigel, I'm a molecular biologist here in Berlin since not working for any of the companies. I would like to counter this bashing of the dogma, because originally it was made kind of fun word by Francis Crick, and he has some sense of Monty Python. So that it was taught in universities, in school, as a kind of dogma, that was terrible, because it was a model, and it was meant as a model. And the problem was that in those very simple cases where you could actually test it in experiments, it worked. Yeah. So then it made it through the textbook, and it was taught, and then it's now being bashed as a dogma. Everybody who's working in biology for a couple of decades knows that it's a good model, but okay, we have other things. As you said, epigenetics. But also epigenetics has not yet come up with some kind of dogma or paradigm. Or how would you call it?
It comes up with predictions like the dogma. Is that what you mean, or no?
It's still a little bit cloudy, this field, because all what influences epigenetics is not really known. So it's hard to grasp, yeah? It's a little bit in the clouds still. So it's very hard to take this to argue this is a new genetic. Certainly one part, but it's not the new genetic. And so not too much focusing on the dogma, just teaching the students that it's a model.
Okay. Short answers now?
Okay. I'd like to pick up on the last point, because I agree. I teach the Central Dogma, and I'm going to reveal my sins. I call it the Central Dogma because it is a model, and for me it's a tool to start my students thinking about how DNA genes relate to proteins. So I wouldn't use the term central dogma in any way to equate with genetic determinism, which is how it's sort of being used a little bit here tonight. So I see genetic determinism as the idea that a trait devolves to a particular material basis, and there's very little or no environmental influence. So I don't see epigenetics either as the new genetics. I just see it as genetics. It's different ways in which the material basis of organisms achieves a means for a trait to cross generations or to cross infectiously between organisms. So there are very powerful traits that are determined by different, what we call epigenetic mechanisms. We know RNAi is very powerful, and we know something of the biochemistry. We know that methylation patterns are a powerful way to maintain a trait across generations, and we know something of the biochemistry. So for me, what we're talking about is a variation in the amount of response there is to your environment. a DNA molecule changes very slowly and is fairly resistant to the environment. You have to give it a mutagen. But a gene that's determined, a trait that's determined by alternate methylation patterns is very responsive to an environment. So I guess what I think is the point we're making isn't that the paradigm of genetics is wrong and that DNA is not a gene, because DNA molecules are genes. And our fundamental phenotypic framework still requires those DNA molecules. But what we haven't been able to do, other than acknowledge that, is translate that into our thinking about how the biotechnology works. There we're still very much in the framework of a determinism, and we're very much frozen on DNA. And likewise, for ensuring the safety of these biotechnologies, we've become trapped in a DNA approach. And that is, I guess that's the point I'm trying to make.
Okay, Ignacio, what's your take on Regina's?
I want to say something. It's great because you build this as a debate, and then you loaded up the forum with friends who have been discussing these questions for a long time. And I was asking myself, how can he call this a debate? Or they call this a debate? So now I get to disagree with this guy, and that's great because he's a friend, so I don't get to offend anyone in the audience.
I'm a friend
Although
so far.
I might come out against it, but it's, I hope you don't take it as a personal attack or anything. But I'm going to attack him and say that yes, it is a sin. you recognized it, and I think it is true in the sense that, listen to yourselves, experts, talking about, if I spend 20 years in the best laboratory in the world, fully funded by a government, then I get it, that it was kind of meant in jest. It really didn't, we didn't really mean it. But I will still teach it to my students as the first thing I teach. How do you fix that together? I don't get it. Because I think we are agreeing that one of the really big problems is that we get young people, and I believe all of you, because you see it in your magazines and you say, it's in my DNA, it's in the DNA of my company, it's in the DNA of the Porsche, it's in the DNA of, everything has DNA, right? And it makes sense to you. So somehow I am part of that sinful society, the society. I was raised Catholic, so I need to find some kind of guilt somewhere. I am part of that sinful society that perpetrates and continues a disingenuous model that the problem with it is that it's so beautiful. This is the problem. So that for all of you and for all of my students, it makes a lot of sense as a deterministic dogma. And even though you and I know that we mean it in a little bit, and we know about history, and we know what Crick said later on, even though he said, I will eat my shoe if anybody shows that there is information transfer from RNA to DNA, and then when it was transferred, I never saw him eat his shoe.
This debate is on.
I think it's very important to move on to a different kind of language so that we can liberate ourselves from the cage of this dogma and this deterministic economics, politics, and lifestyles that we all have. So I am just a simple biologist, and my answer to your question, and to your question, you seem to want a dogma. You said they haven't come up with a dogma, so I'll stick to this one. And I think you're right that we haven't come up with that dogma. My very humble answer to that is, what if I don't have a dogma to give you? And still recognize that this one is doing a lot of harm in the world. What if I don't? My move with my students when I get to this point is to say, I want a biology, part of the problem goes deeper than this, and it has to do with the fact that we try to build a biology up from things, as if biology was about the things. We have all these things that look like levers and cogs when it was Industrial Revolution, and now they look like ones and zeros now that we are in the digital world, but they are still things. My wish, when I grow up and I become a biologist, is that we begin a biology of verbs instead of nouns. Because biology is about action, about verbs. And so the problem goes deeper than just the central dogma. It goes down to the problem of not having a language to experiment with, to build models with, that is a language of action, of verb, as opposed to a language of nouns and things. So I do try, and ecology gives us a lot of examples and ideas to how to deal with this. Systems analysis kind of comes close to it, but they get lost in just simply saying everything is complex, everything is complex. I feel like there is a need for a new language that would accommodate for verbs instead of nouns.
Interesting.
Yeah.
Okay.
Briefly,
we're in the...
It's just interesting, sort of like that you're mentioning that, because I've heard people talking about like we are singing things all the time. Well, actually, this plant is doing potatoing, right? Right? Sort of, it's not a potato and it's stubborn and that's fixed. No, it's potatoing, and what I find, what you said earlier, it's very difficult to replace to get rid of something if you don't have something to replace, because that takes courage, what you're doing. You know, sort of to all of a sudden be a bit in a vacuum and not being able to fix something.
Disorientation.
Yeah? Disorientation. I remember a colleague of mine who was actually a sort of a molecular physicist. No. A particle physicist. And he actually was saying like something very strange has happened to me, and I don't know what to do any longer, because he said actually like things don't exist. You know, the smaller you look, you know, it's made out. Everything is made out of nothing, right? We think we've got a new particle. We look at it. Oh, it's made up of smaller particles. In between is nothing, right? So he all of a sudden really changed his understanding of what all of this was made of. And then he said, I have to stand up in front of my class and teach students the physics. And I mean, if I'm going to tell them what I'm seeing, which is not seeing anything, is they just leave and say like, okay. So one has to teach. Actually, what one knows is not correct in order to help them, to guide, to see what's behind it. But what do we do when we actually fix the minds at one stage? And so that I feel like that's where a challenge is. Yeah.
Thank you.
My name is Ulrich Löning. I'm a molecular biologist and I was a biochemist, and I did my research, among other things, producing some of the techniques of nucleic acid analysis that are later used for genetic engineering. Now, and then I developed and changed course and became the director of the Center for Human Ecology that looked at the philosophy of what humans are doing on the world. I just want to tell you a couple of stories.
No.
Okay, I'll be very brief.
One story, please. Sorry. Choose one story.
I'll do it in one. But I want to compliment all the people on the panel. They've given a terrific story themselves, and I don't really have anything more to add. But just picture the change of one nucleotide in the English language. Change a T into a W. You get to be or now to be. You know, it changes the whole of Shakespeare. Just one nucleotide. And that's what we're up against. It's the DNA code does not code for a meaning, it codes for an attitude, for a play, for a tragedy. It's fantastic, far beyond what we think of as DNA. So there is a model there that we could use, and we can have many other situations of that sort. I won't go on to another story, but I'm old enough to have known quite well Conrad Waddington, who was the first to either adopt or popularize the notion of epigenetics, and it's now deteriorated into the methylation of DNA. That's a deterioration of what he originally envisaged as a verbs and not nouns, DNA process. It's one of process instead of object. as you put it much more beautifully, verbs instead of nouns. Thank you.
So we sure admit that it is with much higher precision that we turn from not to now. And that makes the thing actually quite safe. I understood from the lectures around. Are there more questions, interventions on this scientific level, or would we probably transgress now a little more to what implications this have? Okay, le Chevalier first.
Well, I'm Arnaud Apothecaire. I'm working with Justice Pesticide, and it was a very short question about the dogma itself. And I wonder whether the problems of the dogma not going through with reality is also due to the fact not only about the kind of code, but the fact that there are organisms which are very complex, which very many cells, in a way, which have to interact together. While in bacteria, for example, my experience is we have had, I mean, we, not me, but there have been some successes in modifying bacteria to create insulin, for example. So in some organisms, it looks like at first sight the dogma is going okay. When we go to more complex organism or multicellular organism, it doesn't work.
Mm-hmm.
So we want to have your opinion about that.
Agapito?
So I am from India, working for promoting organic farming and reducing GM crops. The discussion seems to be related to something inside the cell. Either you work in the nucleus of the cell, where central dogma could be not enough understood, and then epigenetics, and then mRNA and RNAi and all that. Don't you think that the important part of the solution lies the technologies and non-technologies outside the cell also?
Okay, there was one question back here. Yes?
I'll stand up because I think it's better for the audio. I'm Brian Wynne, board member of ENSA, Professor Emeritus of Science Studies at Lancaster University in the UK. I'm a physicist by training, but I've learnt some biology, mostly from actually my friends on the panel. But I wanted to return to Angelika's presentation about some of the history of why we are where we are now, dogma and so on. Dogma, of course, as Thomas Kuhn pointed out, is normal to science, and it's even functional in science, as actually Ignacio and Jack and others have been explaining. But I just want to think about the connection between the scientific focus on dogma, central dogma, and genetics, epigenetics, and the political economy of the context in which the central dogma is articulated from the science, of course, and the DNA model and so on, into the world in which science now is. I think there's quite a nice analogy, and we can think of analogy as a pre-model, if you want to think of it that way, between the relationship between genetics, epigenetics, and the central dogma, and the question which is posed by all of the points that Angelika was making about the promissory political economy, as well as the intellectual promise of science, of genetics, and DNA technologies and so on, that actually those promises and our focus upon them and their failure, systematic and pretty much complete failure, over how many years now? 30 years? Is actually omitting a further question, which is about what they have blocked out of the world of society and of science. And that's where I think we should be focusing more of our attention. And I don't mean right now here this evening, I mean after this evening, beyond, into the worlds of agriculture, environment, public health, and of course science and research. Where are the areas of research that have just been stabbed and deleted by this focus of all these false promises that haven't delivered, as the panels have very well articulated, compellingly so? That's the question which I just want to pose it. If we had a different epigenetics of contemporary genetics, and I mean social and political and economics, we would have a different genetics in the world of today, and a different agriculture.
Helena, and then we'll come back.
I just wanted to raise the issue of how these mental processes become fixed, and something to do with not knowing, and how we deal with not knowing. And we seem to deal with not knowing very badly, and constantly look for certainty. I must be certain, I must be certain, as a sort of save it all. But how can we build in not knowing to the way we educate? Because I think it's very deeply embedded in our idea that we must know, that we must be certain. And it's just a small, I think we could find ways of dealing with education and thought that would help us not to keep bashing into these needs for a paradigm shifts quite so heavily.
Thank you. Some responses quickly to especially to the further technical questions, and then we'll move on.
I saw you writing something.
I'm writing something. I can talk. I can talk. That's my problem. That's why I'm holding back, because I'm.
You are?
I think I would like to start with the question of not knowing, because I might get all my time on that, even though I really would like to deal with the question of complexity and how to deal with complexity, and how are we really going to buy the systems analysis and complexity model? Okay, I'm dealing with complexity. Think of another way of understanding the universe that stuck for a long time because there was no other paradigm. The idea that the sun revolved around the earth.
Yeah.
Right?
You were the center of the universe.
Well, for whatever reason, they made you feel that you're in the center of the universe, but it just fitted the evidence.
It did.
If you put me here on planet Earth, the sun does go around the earth. I'm sorry.
And so does the moon.
It does.
Right.
And the moon too. And all those stars, they just turn around me. I'm sorry, they do. But then you start paying attention, and then you start measuring. And the more you measure and the better your instruments, you start realizing that it doesn't quite fit the idea. And what they did back then in Ptolemaic times was that they added, guess what? They had these cycles to explain the movement of the planets and everything. Guess what they added to it in the mathematics of it? They added epicycles. Exactly what we're doing with genetics today, adding epigenetics to it, which is another way of saying, I don't know. I'll just add a little bit more to try and explain the evidence that I'm getting as I look more carefully and more tightly, right? So I think it's valuable to think about it that way, because it is true, we do not have that other language to think about life. And I have to say, it is life, really. It is our life. It is our political life. And I think Brian's point is really well taken. But I want to finish just with the question of not knowing, which I think you're completely right. That we really are not trained, even as scientists, I seem to be very engaged with the question of young people and educating. And in the educational process, different from the training process, right? You train a dog to do tricks. And there are lots of tricks to do with pipettes in the lab. They're really fun. But in the educational process, we fail entirely with this question. And to me, it has to do with the way we define and understand the word science. This same word with the same letters is used in two completely different and opposing ways. What I call big S science, is a practice that presupposes that there is a truth. And the more we know and accumulate on top of it, it's like building a pyramid that takes us closer and closer to the truth. There are people who believe that, and they're always sure that what's below them is safe and sound. They're building that pyramid. They don't need to deal with not knowing, and you present them with not knowing, and their response immediately is fear, anger, really basic emotions that go with that. The other science, quickly, with little s science, which is the one that I want to be ascribing to, is defined by Ian Ball, our dear historian of science friend, who defines it with 4 words: sustained, collective, critical, inquiry. Critical inquiry is the point where we can be trained as human beings at knowing that we cannot really know, but that we are approaching using the best models we have. But that every time my task is going to be to present the model to the reality and try and find how it does not fit. So the training of the scientist, in my mind, of the little s scientist, should be the training to continuously doubt yourself and try to prove yourself wrong, which is a way of really understanding and even honoring and holding not knowing. You know that you don't know. And this is just a way of, so science in a way, and this really bugs me when people come after science and they say, scientists, they're all sold to Monsanto and so on and so forth. I said, don't give it away. There's a really valuable use of that word science as the only way we have to deal in this systematic, collective, over time, sustained, collective, sustained critical inquiry with not knowing, with doubt, and to live in that suspense that is just so fantastically beautiful. Yeah.
One word on the complexity from any of our
I'll go
voices
with
here.
I have something on complexity.
Okay.
I don't think education is the bad guy here. So I'm going to kind of address a little bit of what Angelika was asking about too big to fail with these business concepts. The premise I'm going to come from is this. Companies can only make money or make the most money if they can capture the intellectual property rights of what they're making. And the tools we have chosen as intellectual property rights instruments favor things that we can describe simply. We can describe nucleotide orders in a polymer of DNA simply. We can prove ownership of them because the sequence can be special. And we can reliably amplify that kind of molecule to the degree that it's a gene. Therefore, we can amplify that gene. What has happened is the feedback loops between the pursuit of private enterprise and education have become powerful, particularly in biology. So now what it is not that we taught all these flawed concepts that resulted in people going out and doing biotechnology. Some of that did happen. But now, if we choose to teach something else, our governments will not fund us. Because our governments, particularly my government, the biggest investor in gene technology in New Zealand is the New Zealand government. It's not companies. But they tie almost every opportunity for me to get a grant to doing something with an industry for which I can deliver intellectual property rights to license to them. And it doesn't end there with the educational cycle. It's not just that I can say, well, I'm going to teach you what's the truth, and I'm going to research what I can sell. It doesn't end there. Now, on all of our boards of study, are invitations for industry to participate. And despite my colleagues, when I remind them that industry could mean civil society as well, and other perspectives, they say, oh, yeah, of course that's what we mean. But who shows up? The seed breeders, right? The largest seed companies, the agrochemical companies. These are the ones who participate in the workshops when we talk about our curriculum. So it isn't just that education is flawed. It's the model of public investment in education and research has become too big to fail. Who gets embarrassed if biotechnology doesn't work in New Zealand? The New Zealand government. And who is it embarrassed by? The public, who have paid their taxes to the New Zealand government, who invested in this. And this is the cycle that nobody wants to get out of. These governments do not want to admit for the last 20 some years that billions of dollars of public money might have been invested in the wrong thing. And this kind of comes back to Brian's point. What opportunity costs have we paid because we followed this technology instead of technologies that can't be patented but work?
So I think that was a brilliant introduction to the last round of debate. What does this tell us in the political discussion? Let me introduce you to what our Ag Minister said today.
Oh, okay.
Our German Ag Minister, Mrs. Klöckner, she said, we have to lead a debate that is science-based and not depending on moods. And putting classical genetic engineering in one pot with CRISPR is strictly a mood-based thing. It is not science-based. You understand?
Yeah.
I don't.
And this is a discourse we're having at this moment because a European Court of Justice, which happens to be unchallengeable in the legal thing, has decided that the CRISPR technology needs to be regulated just as any other genetic engineering technology. This has led to scientists starting a petition, a people's petition against the court, right? Reverse this verdict of the European Court of Justice. But on the other hand, it has also led to the Bioeconomy Council of Germany demanding that now the law has to be changed. Now we understand from the court that this is the law. They're slightly more educated in our Rechtsstaat, we call it in German. Well, then we have to change the law. And they said the first thing we have to do is get away with a labeling thing, right? There should be a voluntary labeling scheme, but no longer any kind of mandatory labeling schemes. And that is because you cannot distinguish the natural breeding result from a CRISPRed single nucleotide mutation and so on and so forth, right? So that is one discourse we're having at this moment. And what I would like to discuss a little bit in the light of what we have heard today about the scientific basis and the certainty of science, right, is what does it really mean to have a science-based discourse about the impacts of genetic engineering and the different types of genetic engineering. And also, I think we should combine it with the question of what is the science of intellectual property rights on, be it DNA pieces, be it certain methods of altering them, which is probably the easier thing, or products where I can identify a certain proprietary piece of DNA.
Yeah.
Because that is the fundament. All the business, right? All the huge investments in CRISPR at this moment obviously depend on the question who owns it, right? And we are in a situation where probably the Nobel Prize Committee will wait for the verdict of a patent court before they decide who should get the Nobel Prize for CRISPR, right? This is the real world. And one thing I would like to add before I'm asking you is, when I started campaigning on GMOs in Europe, I was trying to get this legislation before, right? There was a company called Burson Marsteller. And this company got famous because they advised Monsanto's and others how to lead this debate about GMOs. And the mantra of Burson Marsteller at this time was, perception is real. Right? Perception is real as a concept of how do you materialize certain political ideas. But what I hear here from the models, right? This is also a question of what actually is the reality. In the end, I think the reality of Mrs. Klöckner is that science agrees on CRISPR is not genetic engineering, to give you an example. This is the role of science, and I'd like to go into another round of how does that relate to the dogma.
So I am Juliette Leroux, I am working for the Greens in the European Parliament. I'm the GMO campaigner. I'm an agronomist by training, and I have also worked as a regulation officer for some time. I have to say that seeing journalists say that a decision by the EU Court of Justice reading the law is anti-science was probably the saddest thing I've ever witnessed since the signing by Nobel Prizes of this letter on golden rice, which was also a complete scandal science-wise. And so I come to my question is, I feel like a lot of scientists feel attacked by a kind of coalition of anti-science people and are withdrawing from completely from the public debate and maybe don't realize the power plays, including in their own structures, that are blocking them to see what's happening. So am I wrong in saying that, or I mean, what's going on?
You mean little less science or big less science?
I'm meaning the actual scientists.
Yes.
I'm Ute, I'm working for Friends of Europe in Brussels, and I have a connected to the question from Juliette. The question. I mean, when I saw this petition from the scientists, I thought, okay, if scientists don't fully understand the role of the different institutions in Europe, what is the role of the court, and what is the role of the commission, what is the role of governments, I noticed that there's a lack of political understanding about the different roles. Fine. But for me, there are more fundamental questions. For me, the question is, if I read in media comments that the judges took decisions based on fears, on wrong emotion, or believe fact-based decisions, I'm getting concerned about the journalists and about the media in Europe. Because from journalists in Europe, I really expect that they understand the different roles. In Germany, you learn when we are 14 or 15 that we have people who make laws, people who implement politics, and people who have an independent juridical system. And judges, their role is to take decisions based on the existing law. Their role is not to give a scientific definition or whatever. This is not a role. But my question to you is more, this is sort of more. My question to you is, I mean, whenever I hear this, we need to have a science-based decision on whatever. For me, to frame it as an open question, do scientists really have confidence that they are the best people to decide about regulatory rules and how societies should develop? And I'm reluctant to come up with this. For me, it's a joint decision. We need scientists to contribute to debates in society. But we also need others. We need politicians to understand. We need lawyers to understand lawmaking. And we should, if it's a big decision, have a society discourse about it. And science has a key role in it. But if I think scientists should decide how a law is written, I get really nervous. And not about GMOs in general. I mean, we had so many cool excitements about emerging technologies and how great it can be used, and then we learned in the process that actually there was a lot of promises or excitement, but the actual impacts are not beneficial. So for me, scientists have a key role in this wider society discussion, but they should not lead on a process. They should conclude, they should be consulted, but they should not take a decision how a law is written. This is my non-scientific question.
Yeah, would you do that?
There was another question, wasn't there?
Here is an answer.
No, not an answer, a thought about this, you know, because it is, and I know we all share that, it's a very troublesome development we see in the science world, and is part of the reason why we have united ourselves and assembled ourselves in another network of scientists trying to bring another voice to that discussion. And it is troublesome and puzzling to us to see that there is a part of the science community that has taken on this aggrandization, this self-aggrandizement, that they are elevating themselves above some of the, foundations that we all thought we're living on. And it's like we're at least in these circles of elite trained segments of society would never be questioned, would be kind of wired in. I don't want to use the DNA analogy, that they understand that this is our common basis and they understand what that means. But apparently in this field it becomes clear over the years, it started earlier, it really now goes up to a blow, that this segment has been leaving that space. So some of us who've been subjected to some of the discrediting and their kind of campaigning they do have been already feeling that there is this atmosphere of totalitarianism and of authoritarianism that is permeating more and more into the science fields, that you are being vilified, go after you. But then people said, okay, we always had that in science, there were always fights between scientists who believed strong in something. But there was another quality to what we have been experiencing. It was beyond, say, the leakies of evolution, that hated the other part of human anthropology, human evolution. They were fighting over issues and they wanted to be the holder of the theory, and I am right and you're wrong. It was about right and wrong. Yeah. But here it was more. It was like, I have power over you and I define what is truth and what is not. So it was getting into a quality and a dimension that was, for some of us already 10, 15 years ago, really taking on a different vibe, a different taste. And I'm wondering if part of that comes from aggrandizing this field, and that is something we have to then debate as a society. When we put our eggs politically and economically in one of these baskets and say, this is a key technology and we will die, we will not be able to sustain ourselves, we will not be able to produce food if we don't go with this technology. And you can take any technology, doesn't matter which one it is. If you give that much defining power, money power, to a group of scientists, they lose contact to reality. They actually start believing that they are something different. They are above the law. They are the defining moments who say, hop or top even, and they don't shy away from courts. They don't shy away from saying these judges are anti-science or not scientists and therefore we must do away with it and we must now write the law. So this is troublesome in times that we are living in right now of alternative facts, of alternative what have you, and people losing their coordinate system where in the universe they are, and having a segment of our elite, top educated people feeding into this is, for me, one of the most troublesome features I've been seeing in the past 10, 15 years. And this did not fall from the sky. It's been slowly, and we nurtured it with our science and research funding, with the hype we have been generating about it, that we're now asking ourselves, it's too big to fail. Yes, that's an economic, but it's also lifting them. We're losing democracy here, we're losing people who we thought we can rely on and have that fundamental understanding of how democracy works. Apparently they're losing that.
Okay.
So that is very troublesome.
The film man is
I was supposed
Raising
to
his
film
hand.
only, but there's one thing I would like to say, which
Tell us who you are beyond the film.
I'm Sanjay Kumar. I'm a communication scientist, but I'm also a student representative in charge of questions of ecology and consumer protection, and this is how I got involved in this whole issue.
At University of?
At the University of Bielefeld. And there's one example that I would like to highlight here, which I think is highly relevant. And that is the proposed Biotechnology Regulatory Authority of India bill, which was proposed, I think it was in 2010 or 2011, and it was seriously debated in the Indian Parliament. And this was supposed to accelerate the procedure of approval of genetically engineered crops in India. And it was actually giving, the proposal was to give the authority into a 5-member panel to decide on the approval of crops. And 3 of the proposed members were having direct conflicts of interest. And I think the worst thing here was that there was a section on penalties saying that whoever will question this publicly may be put in jail for 2 months. So this was a seriously debated, in Indian Parliament, seriously considered law proposal. This shows how far the influence of the industry on legislation has gone. That in what is called the largest democracy in the world, the Parliament is considering a law outlawing a debate.
I mean, we see this is along what I said right now. You know, where we're moving. We have similar voices also in Europe, where scientists are seriously discussing how to do away with critical people and shut them not only out by discrediting, but physically.
So that's the extreme of it.
More views on this?
Yeah, my name is Ricarda. I'm from the Federal Agency for Nature Conservation in Germany. And I'm from the Federal Agency of Nature Conservation here in Germany. And so I'm a regulator, and I have to deal with regulating GMOs. And so I would like to raise also a question and a point also on this discussion on this CRISPR and new techniques, and should we regulate, and we now will regulate it. But anyway, so when I was, I did talking a lot of also with breeders in the last months, and to get a feeling how they deal with that issue. And I had the impression when we look on breeding in general, there is lots of wishes what we would like to have, medium level of knowledge, and a lot of try and error. So breeding was, at each step of the time, breeders just did with the methods they have a lot of try and error. And most times they fail, and sometimes they get a new breeding line, and then they succeeded and go on with that. So we have a lot of, in this process of breeding, a lot of uncertainty, and people who don't know what they are really doing. And okay, we cross a green flower with a yellow one, like a blue one, so we have some ideas of what we will get, but really not really know why this is, or how the traits are, if it's a gene or is it an epigenetic or whatever it is. And in fact, breeders really even do not care too much if you just get a result of it. So for a long time we accepted that breeding is just working like that. It's try and error, and we get a plant and we will all eat it. And now we have new generations and new techniques, and now we should regulate it. We have another kind of uncertainty, another kind of not knowledge, which is but somehow now different from the former kind of uncertainty and not knowledge. So just provocative asking to you, why should I now regulate and do fancy things and thinking of methods and doing a whole regulating scheme out of something new. Why?
Why just the new thing
Why
and not
just
all
the
the
new
rest
thing
we
and not
don't
the
know
other
anyway?
bit? Yeah.
That's
Yeah.
fine. Okay, interesting question. Right, this is probably the last round now. If anybody needs to say something, order your pint now. Please go ahead.
I think there was a lot of misunderstanding and communication between different groups of researchers, to be honest, because both sides have been a bit dogmatic. Use that word again. So it's, it's of course not great to it's really stupid to want to knock down people in a whatever way. That's a really bad example that people try to knock people out and so on. But at the same time, I think people have been feeling not understood in their judgments and why, and there has been not a lot of discussion about the topics, the scientific topics themselves, which is weird. So everybody's just discussing about the dogma, but not about the scientific topics, no? And for example, completely no GMO is also a dogma. So it is a difficult one, no? So there could be things going together, and I agree that there is probably a different kind of regulation needed. But also, I mean, we haven't talked about this whole trans or mutagenesis thing, not transgenesis, like mutagenesis thing. That is kind of in the middle of it, no? So, and I think a lot of misunderstanding or misperception maybe came from people feeling that CRISPR is supposed to be regulated, but mutagenesis is not supposed to be regulated, and we don't understand all of the non-DNA based changes in both cases. Yeah.
Okay. Here is a last intervention.
My name is Anita Schweier. I'm toxicologist. I was toxicologist, now no longer. And I produced an exhibition with the headline "Wrong Way Pesticides," with 13 plates, and one of the plates is here in a smaller form, and the specialty of this exhibition is that I included 10 strategies of ecological methods. And this exhibition is a big success in Germany and also in Austria and Belgium, meanwhile. And it shows the problems of pesticide application and the political background, and what, by preparing this exhibition, fascinated me very much is the really great number of new publications on ecological techniques, especially mycorrhiza and all these interesting cooperations of bacteria, fungi, and insects, and nematode, and so on. And the idea is that more science in this field would really be an alternative in the story we tell people. We have not all these disadvantages of the agrochemical methods, spoiling of groundwater and all these difficulties, these diseases by application of pesticides. And if we promote knowledge on these possibilities to increase the yield of our food in the field by these methods, we will have much more success than fighting against Monsanto and Bayer.
Well, now, in order to give Regina the last word, I have to take this gentleman for the sake of gender balance.
I'm Michael Dittmar, I'm a physicist, and I've worked at CERN since 33 years now. Well, actually, I think my answer to this question of how to regulate things, I'm very much inspired by, let's say, Einstein, and where he said, well, all the problems we have created, cannot fix with the same methods that created the problem. And I think this is exactly this whole issue. So we should understand the problems we have created, and we need a different method for it. And so just saying, oh, it's just a little bit better, this technology than the other one, it is not the right way. I mean, we should understand that we are in a fundamental, very deep problem in many issues. Basically everywhere where we look, outside, let's say, something that's totally irrelevant to some extent. But in this respect, so we cannot solve the problems with the same method that created the problem. And as long as we don't understand this, we will always fail. And we fail every time in a more dramatic way.
Thank you. So,
I just wanted to comment on the question, so why should we regulate CRISPR right now and not mutagenesis and all the other things we have done, or even kind of conventional breeding? I mean, we had this discussion. I was part in one of the first round of critical discussion on genetic engineering in the 80s in Germany and also in other countries. And I mean, for sure we dealt with all these questions, and there are differences between genetic engineering and conventional breeding and also mutagenesis and all the other things. And there all are, again, differences between CRISPR and conventional breeding. And I don't want to elaborate on this, but I think what is really important is that we do not separate ourselves from our own history, yeah, and also from the history of the public and scientific debate. I mean, for being in this discussion for almost 30 years now, I'm sometimes quite, I don't know, depressed or hopeless or so, but because all these things which have been discussed already, and a lot of work has been done and arguments have been put forward and not being refused by science and so on. I mean, they're just gone. They're in the papers. They have been published, and so why don't we just read a little bit and then have the arguments already? And so just let's take serious our own history of arguments. And I think it was in the United States, in England, it was the same, that there were a lot of very bright, critical scientists active in refuting this kind of simple thinking about it's all the same, yeah, and mutagenesis and simple and conventional breeding. So and we have this economic aspect and the patenting, I mean, which speeds up the whole thing in a completely different way than conventional breeding have ever been dealt with. So just let's kind of remind our own history.
Stick to our history.
Very good.
Is it necessary, really?
I'm not sure. I'm not sure, but I have the feeling I should say.
Then let's talk about it tomorrow and give them a last word, not too long, and some concluding dogmatic message, please. Now,
what's your dogma?
Go ahead, Ricarda.
Yeah.
We've been waiting.
Okay. Great stuff. Thank you. I think we are all of us are in the same boat. We all have to deal with the various problems we have and how to deal with it and find solutions. And we need to keep our minds quite broad in that and not get them too fixed, because otherwise we might actually not see the right solutions. Now, let me go for a moment to the issue of hype, right? Which we often get like as solutions. Promise this, promise that. Now, what is the role of hype? There's quite a number of roles, not all of them are bad. One of it, of course, is hype. Well, it attracts funding, it attracts investment, you know. I mean, these days, a lot of money comes along, millions come along in one go, if you have hype and can somehow sell it. It's also what, you know, the business model is in this. It's sort of, you don't actually need to deliver because you get the money invested on the promise. And And if it at the end doesn't deliver, I mean, we are later, right? So I mean, that water is gone under the bridge, or that money is gone under the bridge long ago. Now, but there's another role of hype, which is it will actually do what it's doing, make people listen and say like, hold it, if that is possible and that is possible, how does that fit together? And if I all of a sudden can make one organism do completely other things and it gets released, basically what it does, it sends an alert signal. And in that is, how do we regulate that? That is another answer to hype. It's the response to the possibilities that are promised and actually the problems coming with it. Then you hear it, for example, like I have that in the debate of gene drives in the moment. Gene drives are organisms which you release in the open in order that they will actually spread into the wild populations, that they will either eradicate those populations or change them. So it's the opposite of how GMOs were tried to kept contained. And now there it was sort of, yes, and we can do them and we can sort of basically wipe out malaria and wipe out all the mosquitoes and then malaria will be gone and we have the global gene drives, and then people started going like, hold it, what does it mean for the environment? Now you get all of a sudden like, no, we don't get it to work that fast. And, because we started talking about the regulation, and you get like, no, it will not work. Actually, we are far away from it, and, calm down, right? So we can see sort of that play in it, but there is a lot of investment behind it. And what I find interesting as well is just coming back to uncertainty for a moment. We have a scientist, to get money from government or from anyone, one has to sell certainty. Therefore, we have to get ourselves into a mindset of certainty. Otherwise, if I can't deliver or that, so therefore, there is almost this notion like one is not allowed to not know, and that was so much part of science. I've actually read some articles from young scientists who are saying like, I'm at the wrong place here because actually I feel utterly stupid, because I don't know the answers. I don't know. I don't understand this, but I'm supposed to understand this. I don't know what it's doing, but everybody's so certain, and I'm obviously not made for this. Exactly that is how scientists should feel, because it is not stupid in the sense of, not being thinking, but rather like, no, acknowledging that one doesn't know something, and then one researches. So I feel, and there is with your point is, we cannot say, for example, that CRISPR is by definition safe. You can make with CRISPR a lot of things that are highly problematic. You can even weaponize it, right? So therefore, just for the few examples that might actually turn out to be fine, to not regulate would be madness, because then you regulate and those are fine, okay, they can go ahead. So I feel like you were bringing it in from the other direction, and I just wanted to reflect that back.
Thank you.
I don't have anything to close, because I really would like to leave. There's so many questions that are left hanging, that I hope you go home with those open questions that I hope we were able to raise. I recognize the, no, I'm not going to say that. It was about the politics. What I want to end with is simply an advertisement, because it's not the end of my participation here. You guys have been very generous. This place, the guests, or the people who brought us here, who paid my flight to come here, the city of Berlin, incredibly generous place, so much so that I get another opportunity to talk. And I'll be doing it on Friday, and I will be going after precisely the historical honesty. Can we go historically honest at these questions, with the interest of digging deeply into the where did we lose track of honesty in that historical development? It's very interesting to look at it and go back mostly through the 20th century. I'm going to be doing that historical approach. But for tonight, I really, really hope that you guys leave this room disoriented, but liberated.
Yeah.
Liberate.
Yes.
Jack, some more certainty, please.
Okay. Certainly, I'll do that. I thought that last session was amazing. There were so many things. So I'm going to really discipline myself and just pick one to talk about, and that is the question of why should you regulate. And I'm going to bring forward maybe not the two most important, but two that really attract my attention to why you should regulate. The first reason is that CRISPR, TALENs, ZFNs, other oligonucleotide-directed mutagenesis techniques of that type are fundamentally different from radiation and chemical mutagenesis in the real world. Mm-hmm. And that real world is that if I want to buy a cesium source and put it in my garage, you can be sure I will be visited by a number of security agencies. If I try to buy the mutagens to do chemical mutagenesis, I have to be at a university or a company that's regulated for those things. So the way we at least ameliorate the potential for harm from chemical and radiation mutagenesis is that we don't let people do it. It's a really restricted pipeline. But if I want to do CRISPR, I can order all the parts. I can go to Sarah's databases and download any sequences for anything I want. And I can do it in my garage. So the only way to capture this, the only way for a red flag to go up is if we regulate it. Just as a parallel to how we regulate the inputs to chemical and radiation mutagenesis. And remember, we had a case not long ago. Researchers at a university, on purpose, made horsepox virus from mail-order DNA kits. This is similar to what I'm talking about because those tools are not regulated. My government says these DNA molecules and RNA molecules are grass, generally regarded as safe, so they are not regulated. And that's one of the reasons. The second reason is that I think, like Ricarda, it's a type of framing to say, well, you can't tell if that was an A or a T or a G or a C anyway after I've done this. And I don't think that's the point. For example, if we are struck by an asteroid, we will be flat and uglier than I am now. It would be the same if I were hit by a truck. But because I can't tell what killed me, that doesn't mean I'm against speed limits. It does not matter if I can tell if the impact damage was from a truck or an asteroid. I still want to regulate how fast trucks work because my exposure pathways are different. I don't tend to walk in front of asteroids. I can walk in front of a truck. It is not simply about the nucleotide. It's about the context. And there's a lot to that risk assessment. And when it comes to things like CRISPR, you might occasionally change one nucleotide, maybe. Most often you're changing more than that because you're introducing a break and then the cell is just filling that in with stuff. But that's not even the point. Even if that is some of the products, you can simultaneously change multiple parts of a single gene or multiple genes in a single genome to the point where those changes are indistinguishable from transgenes. And you can do that quickly. So here's the point with CRISPR. You regulate it because you can't be guaranteed that the outcome is a single nucleotide change, indistinguishable from the degree of change you would get from transgenesis, either on purpose or by accident.
So as long as we can't regulate the universe.
We should. Regulation.
Better regulate
yes,
the
regulation
trucks, right?
is the one thing that we as the public have a voice in. So why would anybody be anti-regulation? It's sort of like saying you should not have power. We have only as a public the regulator to protect us from things. And sometimes that means we don't like it, And it may not always be equal and fair, but it is really the one thing we have against concentrated financial power is regulation. You are. In fact,
Oh my God.
you're not entitled to. You're expecting you.
Yeah. But you can make it a real short algorithm.
I will make it very short. So I will put all of these discussions into a bigger context. And I don't know if it's the case for Jack and Ignacio here, but I am here because I can do the research that I do back home, right? It's blocked in Brazil. I don't know if you have been following the research. But it's also the case that GMOs are being produced in Brazil, and they are being eaten by Europeans. So,
our animals.
Yeah, exactly. So if it is the case that we really care about this issue, we should also go back there and try to understand and include these into the debate. This is very nice. The European Court ruling is very nice. Brazil has already cleared one CRISPR organism, a yeast, January this year. So it will be reaching somehow our plates here.
Yeah. Yeah.
That's the context I can add.
That's lovely.
Angelika, you want to close the cycle?
Yeah, I close the cycle, so I endorse, of course, everything you've said, but for me, and that rounds it up with the organization we're having, the Network of Scientists for Social and Environmental Responsibility, it is about responsibility and accountability. And that is what comes with regulations as well. It's the only way the public, we as a society, can keep track and can hold people accountable to what they do and keep track of what they're doing and bring them to accountability if something goes wrong. If we leave this out, and that's why they are vividly fighting regulation, it's because they don't want to take the responsibility that comes with it, you know. They want to take the profits and the benefits that come with it, but all the responsibility and accountability, no, they don't want. They can want this, but we don't have to give it to them. So that is what we have to make sure. And this time, that's another issue I really like to see. Last time they promised things, and we went through the list, it's up here, without a timeline. Now I want a timeline. When they come and say, we promise we deliver this, and I want deliverables and a timeline. That's what I have to deliver when I give a proposal and try to get a grant. I have to say, when do you deliver which product? And if I don't deliver, I will not get any money ever again. And this has been completely dysfunctional in this field. They couldn't promise anything they wanted, deliver nothing, and still get more money. So that broken system really has to be fixed. This time I want deliverables, I want time. They can choose the time, but if you do not deliver on that time, you have to either give the money back or you have to explain why you couldn't deliver and are forced to go over your science and actually do the proper analysis. I think that would be...
Thank you very much.
Yeah, the Berlin airport, don't talk about that.
And I just want to alert everybody here that these are exactly the kind of discussions that usually happen in this room.
Really?
Yes, because you're sitting in a bank. And the GLS bank serves its customers here usually, and I think it is worth a big thank you to the GLS Bank for having us here today. And thank you very much, professors, doctors. We are deeply enlightened and completely confused. That is really good science with a small s. And thank you all for coming here, and we'll see many of you tomorrow just on the other side of the road at the Heinrich Böll Stiftung when we start the GMO Free Regions Conference. But for today, thanks for your attention, thanks for your compassion. I really enjoyed